Buckle up for AEC Trailblazers, the Founders Files, where we crack open the stories of the brightest minds in the AEC startup scene. Forget institutional pitches. We're diving deep into the real personal journeys of these industry disruptors. Get ready for some casual chats firsthand.
Hello, and welcome everybody to another episode of the AEC Trailblazers, where we interview the most amazing founders from the tech scene of the AEC. Here with us, we have Bob Dahlstrom. He's the CEO of Apellix and a leading innovator in the drone technology. With a focus on safety, he has pioneered power, wash, and NDT drones, revolutionizing industries and saving lives. His extensive experience in software architecture, business leadership, and entrepreneurship has led to numerous patents, awards, and publications. Bob, welcome to the show.
Thank you. Happy to be here.
Did I miss something from your bio?
No, that's great.
That's a really impressive bio, but can you tell everybody where you're based?
We're in Jacksonville, Florida.
That's such a beautiful city. Like, I'm based in Miami and I like it, but it's too crowded. So I feel Jacksonville has all the good stuff of Miami, and at the same time, it's a little bit more quiet and you can enjoy beach and everything better. I don't know if you feel the same way.
Yeah, it's nice here. I grew up in Miami, but I've lived in Jacksonville for the past 24 years. So it's Jacksonville is home, and that's where I raised my daughter. So for me, at least, it was a great place to raise a family.
Nice. Yeah, you made the right decision. Like, Miami's getting too expensive, so it's not even worth it at this point. But before we get into all the amazing drone stuff that you guys are doing, can you tell us a little bit how you got to this place? What did you study? Where did you study? And how the young Bob became adult Bob?
So I actually grew up, my dad owned a hardware store. So I grew up, very mechanical, doing things with my hands, working, helping people with plumbing or electrical and all sorts of different things. But then I went to college in Florida and then also in California. And then when I finished college, I worked for the legislature for a bit as a policy analyst. Then I actually went on to teach college at Tallahassee, Florida State University. And my daughter was born then, and my wife was also teaching college in Tallahassee at FAMU, Florida Agricultural Mechanical University. And I came up with an idea for a software program. And so I ended up launching a program and moving to Jacksonville, because back then, this was the turn of the century, it was last century. Back then, software programmers had to physically be in the room together to write code. And so there were more talent in Jacksonville for software programmers than there was in Tallahassee. So we moved to Jacksonville. I started that company, and after about 15 years, it was finally successful. And my wife and I owned a beach house, and it needed painting. And working my way through college, I actually painted houses. So I'm like, okay, I've got some time now. I can go paint this beach house. And it's pretty big, because you drive underneath it and there's 2 stories above it. So I had the scaffolding delivered, and then I'm on top of the scaffolding on a ladder. I'm up there painting, and, I'm like, I'm not in college anymore. There's got to be a better way. And I'm like, drones. To me, drones are software because they're flying computers. So I'm like, okay, because my background is software. I love software. And so I'm like, with software, keep the drone the right distance from the wall and apply paint. But then I'm like, that wouldn't work. Paint's really heavy. Battery life is limited. You'd have to land all the time and swap out the batteries and add more paint. And I looked down to the ground, and that's where the paint compressor was. And I'm like, eureka, keep the paint on the ground, the power on the ground, the pump on the ground, bring everything up a hose, and then be able to paint. So I built a prototype that actually worked better than expected. And then I went heads down into developing the company. And that's the genesis of Apellix.
Like, when you said I built a prototype, I was, because it's not because you're you're not talented, but what you're saying is so hard to do, because it's not only about just fly drone, just throwing paint to the wall, but actually, the pressure in the amount of paint, and also the speed of the drone. Like, it's so complex. I was imagining, The Simpsons, when they create that shotgun to paint Marge's face. So how was that for experience?
That was very hard, and that's actually something we're still working on. So we now have a small contract with the U.S. Army, and part of that is to develop the spray painting drone. So that will be launching different versions at different times. So next year and then the year after. But yeah, you're right, exactly. And that was one of the surprising findings. When I had the spray painting drone and I was painting and manually flying the drone, you would get cognitively fatigued after just a few minutes. And you were happy to land the drone and give yourself a break, just because the minutia of controlling the drone to try to keep it stable, to try to keep it the right distance from the wall, try to keep it moving at the same speed, at the right altitude, all this at the same time. You're just trying to make all these adjustments, and it just fries your brain, which is why the software is so important. Because maybe as a human pilot, you can make 1 or 2 adjustments to the flight per second, but software, you can make 500 adjustments, micro adjustments per second. So that's why, I call drones, software, because they're flying computers. And without the software, I mean, think about it, right? With a drone, for example, our power wash drone, which we have in the market now, that's doing amazing things. It has 8 motors, and each of those motors, just to hover, is spinning at a slightly different speed. So it's got maybe a couple hundred adjustments per second to the flight just to keep it to hover. So it's very complex.
That's so interesting. And nowadays, let's say, true cleaning, I bet it's a little bit, just a little bit easier than paint, because if you just clean something that you were not supposed to clean, it's not as bad as putting paint on a window or something like that. Right?
Exactly. And the tolerance for error is much higher. So if you're outside of your, the transfer efficiency ratio is where you want the paint nozzle to be, so that you optimize the amount of paint that gets on the wall. If you're too close, the paint's going to bounce off the wall. If you're too far, it's going to turn into mist and blow away. And so keeping it in that zone is important. But with a power washing drone, for example, if you're 2 feet closer than you should be, or 2 feet farther back than optimal, you're still going to get the building clean. It's not that critical. So even though it requires precision flight control, and even though any time you're flying a drone close to a structure, it's extremely dangerous. You have to have a custom designed drone to do that. The tolerance is different. So the precision flight control to make sure the drone is stable is of critical importance. I tell people a drone needs 3 things to fly safely. One is it needs to know where in the world it is. It gets that from GPS. But as you get closer to a structure, if you're in a city and there's like a canyon effect and you're down there where the drone can't see the satellites, you don't have GPS. The other thing it needs is which direction is it headed. It gets that from magnetic compass. But if you're flying next to something, if you're close to something that's metal, big piece of metal says, hey, I'm north. And so the drone doesn't know which direction it's flying. And then the third thing is, just like airplanes, it needs to know how high off the ground it is. It uses barometric pressure. When you're close to a building or a structure, the barometric pressure readings are all bad. So to safely fly a drone, you have to compensate for all these things that drones were not, designed to do to get it to be able to perform and do tasks at elevation close to or in contact with structures. And that's what we specialize at Apellix, that precision flight control, all those technologies that are needed to enable a drone to do something that was never really designed to do.
I have such a big respect for when people say they do hardware or robotics and software development at the same time. It's much, much more harder than just doing, a virtual platform doing software. But if you add that you need to make the hardware fly, the complexity is much, much, much more higher. So I have such a big respect. Being a software developer, I bet it was hard, but also I'm just I'm just a geek, and I'm just curious on how was the process on, because I bet you started coding, right? And you had to do like a lot of tests to make sure this is safe. So how do you end up doing all the tests that you need? So you code something, you take the drone, you take something, how does that process works?
So it is a lot of iteration in the software code. So one of the interesting thing was my first company was a software company, and then I started Apellix, and we were developing software. Again, I call drones software. And we're developing these drones that are hardware and software, but we were also making our own integrated circuits with its embedded software code. And so that was super exciting because at the time, a lot of the technology wasn't there to do some of the things that we needed to do, because to fly these, you're using a lot of sensors and you have a lot of data, and you have sensor aggregation where you're fusing the data, where you're cleaning the data because it can have erroneous information in there. Certain sensors work good close to structures, others work better far away from structures. So you've got a lot of sensors, a lot of data, a lot of software program that has to take into account when you're building these drones, and a lot of iterations. And so actually the early days, I was telling our programmers, if you're not crashing, you're not iterating fast enough. We're finally to the point now for the last several years where we haven't crashed, which is good, because we've got that core skill down for that precision flight control. And we know we're doing so well now that all the software we're developing are all augmentations to that core flight stack.
How many drones did you crash during the testing phase? I mean,
well, it'd be the same drone. We just repair it and then go fly it again and crash it. So we've had several crashes, many.
Oh man, that's so interesting. And also going back when you mentioned, which is true, like if a human has to make adjustments, the capabilities are limited, right? Like you can only make a couple of adjustments every second, maybe. So how does the process works when, let's say I have a building and I wanted to wash the whole facade? Like I just map it out and then the drone will just do the work, or I have to still manually do everything, or it's just a mix between, I don't know, AI making adjustments and me just giving like the overall directions? How does that process works?
So right now, the power wash drones that we have out in the market, and we've got a lot of them here in the States. We have 12 countries internationally that we've sold them to. They're all predominantly manually flown. So the operator is flying it next to the structure and applying the chemicals and then applying the water to rinse the chemicals off. Or they're using the pressure, right, with water with high pressure to knock off the dirt or grime and things. However, we have a contract with the U.S. Army. So the Chemical, Biological, Radiological, and Nuclear Defense Division of the U.S. Army saw our painting drones under development, saw our power wash drones, and they approached us about helping them develop a solution for decontaminating assets in the case of chemical or biological warfare. So, for example, if there's chemical warfare and they drop some chemicals on tanks or troop movers or any of the Army's assets, right now it can take them up to 10 hours to get them decontaminated and back in service. We've worked with them to automate that. So our drones now are in process of automating it so that the drone actually flies up, locates the target, the tank or the truck, goes up to it autonomously and washes it. Then it scans it looking for any contaminant and maps out where those locations are where there's contaminant. Then it goes back and it sprays paint to encapsulate or neutralize the contaminant at those areas. And so we've taken a process that took, maybe up to 10 hours down to 10 minutes. And we've removed soldiers from harm's way. So there's not soldiers out there in safety gear, right, in suits, hazmat suits, washing things down and painting things. They're somewhere else controlling a drone or pushing buttons, and the drone is doing the work. So it's a lot safer as well as a lot faster and a lot resource intensive. And so it's actually really, really fun to work on this project because the Army has told us once we get a little further along, they're going to be shouting from the rooftop that they have this capability, because what we've done is we've negated the advantage to dropping a chemical or biological weapon in the first place. So it's actually an example of a drone that can help prevent war.
That's really interesting because it's so versatile. Like it's not just about like cleaning buildings, which is a huge task. There are so many buildings that need that. But doing something like that is just insane. Do you have any other like examples of where you can see big potential on projects that comes to your mind?
Yeah, especially more related to AEC. For example, I was speaking with one of the architects for the city of Neom, and he was telling me he had designed a visual technology to help the city blend into the desert when you're looking at it from a distance. Kind of like certain paintings, when you're up close, you see dots, and when you step back, you see a picture. So he was telling me that with the spray painting drone, we're enabling him to actually actuate that technology. So he made the statement that we have changed architecture forever. And so if you think about it, there are a lot of instances where an architect will design and a building will be constructed that you have to figure out, once it's built and constructed and used, how is it maintained? How is it cleaned? How is it repainted? Those types of things. And so by having a drone able to do this, we have just removed some constraints from the geometry, right? So you can build more geometric complexity into your construction designs because the drone doesn't have that limitation that you have if you're using a lift, for example, or if you're coming over the side from the top with people rappelling down with ropes.
It's so interesting. And you foresee at a certain point that, because like you said, part of it's manual. You foresee that at a certain point, I'm going to be able to just tell the drone, like, here's the 3D model of the building, and select, I don't know, I want this part of the facade and this part of the facade, and use this type of colors, and just go and do it.
Oh, absolutely. Absolutely. And that's what's in our patents. So I've got 6 patents. One of them I'm most proud of is we have a software patent. And it's really hard in this day and age in the United States to get a software patent, but we have a patent for spray painting or cleaning with drones for the software to control that. So having those patents is important, but also that sets the vision for doing just that, where the drone will be able to go and paint something based on the commands you give it. And that's part of the beauty of the platform. You mentioned earlier how versatile it is. Yes, we're power washing, we're painting soon with these, but we're also decontaminating tanks and trucks and troop movers, right? So that's one platform, the drone. And because it's a platform, it can do a lot of different things. And so having the ability to respond to market forces, right? So, for example, like the architects telling us, we want to design a more geometrically complex building, but we don't know how to build in railings to put a sled down the side to be able to clean it. Having those types of feedback from the industry helps us develop tools that can propel the industry forward.
That's so great. And I was also thinking that I feel drones is like any other technology, right? As soon as it's created, and it was created, I don't know, like 20 years ago or something like that, like more popular, like you get a hype, and then then it's like, well, it's not so good, but it's going to be amazing in a couple of years. And I feel drones have gone through all of that. But for me, it's just a feeling. That you have been working with drones so much. What do you feel has advanced a lot in the last years, and what do you feel it needs to advance more in the coming ones?
Oh, you're exactly right. For a period of time, we had the Gardner hype cycle above our printer. So you look at it when you go pull a piece of paper off. And for drones in general, especially the camera drones, they're through that cycle. They're a mature product that's been out there. Power washing drones and painting drones, there's still a lot of hype around them. So they haven't made it through that trough and back into the thing. But anytime anybody says, no, drones will never be able to clean windows, all I got to do is show them videos. Like I said, we're in 12 countries. We're all around the world. We got our customers out there doing these amazing things with the drones. It's really super cool. But one of the things, coming back to the idea about a platform and the hype cycle, is the platform now, because it's a drone, it's a sensor platform that flies around with all these sensors and can do all these things. So if we're cleaning buildings or painting buildings or whatever, we're using those sensors, but we're also able now, as technology advances, to add in the machine learning and the artificial intelligence to the computer vision on these things. So one standards body I'm working with in the coatings industry, we're putting together criteria for localized corrosion underneath paint, because cameras can see things the human eye can't. And so using artificial intelligence and computer vision and neural network and learning algorithms, you can actually train software to recognize paint that has a corrosion behind it that you may not see with the naked eye. So all these technology advances accrue, those benefits accrue to the platform that Apellix is running, the drone. And so as those technologies improve, the usability and the functionality of these systems just get better and better. And that's one of the things about the painting drone that the painting companies absolutely love, is an auditable data record, right? So right now, paint goes up all the time. Sometimes there's a failure. The painting contractor blames the paint. The paint company blames the contractor. But if you did it with a drone, right, we're recording the ambient temperature, the barometric pressure, the relative humidity, the distance from the wall, the speed the drone was moving, all these factors that go into an auditable digital record. And from that, you can do all sorts of things with AI about learning and help the chemists that actually develop the coatings to develop better products, because now they have data.
That's so interesting, how the impact, never thought we could go and reach even the guy who is developing the coating or the paint. But I do feel it can also improve so much on the way we maintain buildings, because nowadays is like I know a lot of realtors that manage buildings, and like facility management it's a pain, because sometimes it might take you a month or two to clean a building or something, and you need to call the person, but the next day it's raining, so it's not going to come for a couple of days, and then you just hit on the last day, like, you know what, it finished painting, and then you make a calculation of like, you know what, in 3 years we're going to paint again. And the reality might be that in some places you need to repaint or re-clean again in, I don't know, a year. And in other places that there is not a lot of sun, a lot of wind, and it could be on the same facade, right? You might need to clean it in 3 years. So sometimes it's you end up cleaning or painting too much, or not cleaning and painting enough. And that's a lot of money and inefficiencies.
Yeah, and you mentioned scheduling. That's one of the pain points that we hear from industry all the time. And for example, in the UK, when a new building construction is completed, before they turn over the keys to the owner, they do what's called a wash down. So it's not a cleaning. It's just generally they're just spraying water, not using any chemicals, just water to clean things and wash it down before they turn over the building. Well, what happens is there are financial incentives to get the project done on time. There are disincentives if the project is late, and everything always backs up until the last day. So at the last moment, you're trying to get something in there to clean a structure. Like it's a 20-story building, right? You've got to bring in lifts, you've got to bring in the crews, you've got to, mobilize this, you've got to get the lifts delivered, you've got to, maybe drive them across the freshly installed grass, whatever it might be. There are problems with that approach compared to doing it with a drone. The drone is so fast and so simple and so mobile that you can just put it up there, do a rinse down of the building very quickly. And so that alleviates one of the pain points, because scheduling, because those financial incentives and disincentives, and the fact that the washing is the very last thing that happens, having the agility and the speed of having a aerial robotic solution come in there and do that unlocks a lot of value for the construction companies.
That makes so much sense. And I'm also curious, now that you mentioned the difference between doing it manually compared to a drone, how do you deal with permits? Because like legislation, I bet varies not only by states, but countries. There are countries without legislation, you can just take a drone and do whatever you want. And there are others that you need a guy who, it's almost like a plane pilot to fly a drone. So how do you deal with that?
Oh, this is very diverse. So we've helped a lot of companies get their regulatory approval from the governmental entity of the country that they're in. And it's been quite interesting because you have some countries that are very, very restrictive. Like the maximum height of these drones is 200 feet because it's based on the weight classification. And they're built for the 55-pound weight classification. And by the time you're all up on your weight, the higher you go, the more weight, you top out at 200 feet. The other thing is if you're cleaning at 200 feet, it starts to get hard to see where the water or the chemicals hitting the building. So you have this natural limitation. But one of the countries required the drone have a parachute. So if the drone falls from 200 feet, it takes 90 feet for the parachute to open to even start activating and slowing the drone down. So that poor company had to pay us non-recurring engineering funds to install a parachute and integrate it with our autopilot so that they could get regulatory approval within their country. Then there are other countries where, like you said, it's a lot easier. The majority of our market is here in the United States, and it's pretty simple. And a lot of companies follow the FAA, the Federal Aviation Administration's model for regulating these aircraft. And here, all you need is a drone pilot license for the most part. And there are certain restrictions, like if you're close to an airport or things like that, you may have to get flight clearance. But majority of the time, you don't even need flight clearance because you're flying in an open space. And you're also, you're flying at the height of a building, maybe 20 feet above a building. So you're not in the airspace where you're going to collide with aircraft. So it's not that onerous to get regulatory approval or authority here in the U.S. But you do have to abide by all the regulations and rules.
So basically, mostly in the U.S., it's just about having a pilot with a drone license, and that'll be all.
Yeah, but it's also very important to let people know that there are complexities involved in this, because I tell people there are three things you need if you're going to be cleaning buildings with a drone. The drone is only one of the three, and not even the most important, right? So you need the drone, you need the equipment that you hook up to the drone, because this hooks up to reservoirs and pumps and hoses and all sorts of things. And then the most important is you need the knowledge, right? You need the knowledge of how that equipment works. You need the knowledge of which chemicals to clean with. You need the knowledge of how the drone works. So all that fits together to make a coherent package so that you can go out there and be effective. Because if the equipment works perfect, the drone works perfect, but you're using the wrong chemical, the building doesn't come clean, you failed.
Interesting. No, that makes sense. And I want to add a fourth, I think bullet point to the equation, which I guess is what is going to happen when drones are just flown by AI? You're not going to have a pilot anymore. So,
and that's part of what
is that going to work?
Yeah, that's part of what we're working on in the second generation with the U.S. Army for the decontamination. So part of that contract is it stipulates that it's dual use technology, meaning that whatever we develop for the Army is also made available to the market in general. So there will be, as we develop this product, automation continually added, because right now the most dangerous part of these drones is the human pilot. And so as you remove the pilot, you're increasing the safety.
No, and it makes sense. It's just that I feel legislation when dealing with innovation is always behind. So you might end up coming with a drone that flies itself and the pilot is not doing anything, but you might be required to have a pilot with a license when it's not doing anything at all. But do you think at a certain point, there's going to be a requirement of, I don't know, the parachute, maybe not like the parachute, but a switch that you can just turn on and off, and that I don't know, even if it's fly by AI by itself, the pilot must hold, I don't know, the controls all the time, even if it's not flying or something like that?
There will be, because that's the legislation now, right? The pilot there's a pilot in command, and that person is responsible for that aircraft. So even, for example, our developmental spray painting drone, the way it works is it's kind of like a train, right? There's an engineer that's holding a stick on the train, and if they fall asleep, for example, they let go, the train will stop. The drone that we programmed is the same way. You have to hold the button on it. If you let go of the button, the drone will stop and hover. So there are techniques to one country. We've put the drone in, has what's called a geocode, which locks it into a certain work area. So that you have to always be within a certain distance of the controller, and you can't go outside of that boundary. So there'll be technological solutions. There'll also be regulatory solutions. And the regulatory authorities are there to keep us safe, right? There's a reason they regulate drones, because they don't want them, flying in the open air and colliding with an aircraft and causing an issue. So, the drone manufacturers like Apellix have no problem with making sure that we comply with all those regulations.
Interesting. I was imagining, I don't know if you remember, it was not an official thing, but there was a video of, I think it was Amazon, that it was supposed to come like a big ship on top of the city, and then smaller drones delivering packages to houses. And at the beginning, everybody thought it was an official release from Amazon, but it was not. But do you think something like that is eventually going to happen with, I don't know, like painting or something like that?
Yeah, it might. Now, I remember the concept was actually a patent that was approved, where a blimp was up there, and then they would have drones fly up to a platform, pick up a package, and then fly down and deliver it. But yeah, I see the future is so wide open, and the use cases are so diverse because it is a platform that could be utilized so many different ways. There's going to be lots of innovations and lots of different things added.
What do you think are the current biggest limitations of drones, aside from the pilot? Like maybe, I don't know, batteries and something like that?
Definitely batteries. So, for example, you mentioned the drone that fly from the blimp and make package deliveries. The concept could be similar, where you've got a drone, you press a button and it flies to a house, right, and paints that house. But the limitation is going to be batteries. Our painting drone that we have developed right now has power from the ground, so it can stay up indefinitely. We will have smaller drones that would do touch-up, right, paint for a small amount of time, but due to battery life, they would have to land. So as technology for battery improve, that's going to improve the functionality and the capabilities of the drones. Just like self-driving cars that use batteries, as the functionality improves, you'll get better performance out of the batteries, longer time between charge, longer distances, those types of benefits. Again, being a platform is great because as technological improvements occur, that benefit accrues to the platform. So as sensors get better, as software get better, you've got a platform that's using sensors, that's using software. As batteries get better, you've got a platform that's using batteries. So all those technological advances advance our technology and our platform at the same time.
Yeah, it's just insane. Also the cost, like cell phones, right? Like you can even get a really amazing cell phone with, I don't know, $100. Yeah, sure. The latest one is going to be $1,000, like the iPhone, but I feel the same with drones. I remember drones at the beginning were really expensive, big, and hard to use. Nowadays, you even have, those small drones that follow you and take you pictures automatically, and you don't even need a license technically because it's like really small and it only flies like 5 feet from the ground or something like that. I guess is the maximum height they fly. So, do you foresee that in the future it is going to be that like almost every house would have their own drone, not only for painting and washing the house, but I get for, I don't know, getting groceries or doing other stuff?
I don't think so. It'll probably be more of a services similar to Amazon deliveries or UPS. They have their trucks that deliver. They may add drones that also deliver, but The homeowner is not going to own the truck that takes packages or the drone that takes packages. But in architecture, design, and construction, going back to your cell phone example, years ago, communication was an issue. Now with cell phones, it's not an issue. Years ago, when drones first came out, they weren't used in construction and design and architecture, but they are now, right? Because they have benefits that can help us in the industry. So those taking those camera drones and kind of flipping that model on its head, instead of having them fly far and fly fast, by tethering them and having them fly slow and fly close to structures, that's enabling us to have a platform that can now do work at elevation. And the beautiful thing about that for the construction industry is we can remove workers from height. And as we know, the number one cause of death in the U.S. From workplace is falls. So anytime we can remove somebody from elevation and put an aerial robotic system up there doing the job, that's great for everybody involved.
That makes so much sense. And it's true, like working construction for a long time, and that's the biggest risk when you're doing a construction site. But I also think that it could even happen that you help efficiency, because like you can even have drones, I don't know, painting during the night or doing cleaning during the night when nobody's working, and then during the day you can just allow workers to keep working on something, or there's limitations in terms of the hours you can use drones.
Oh no, they can be used 24/7. Yeah, and
there is no. Well, I guess you're going to have certain sensors to allow you to see.
Yeah, unlike humans that have to see something, right? The drone has cameras and vision that can see even when it's dark. So it can work in the dark.
That's pretty cool. And also the you feel that, I know not a beam or something really heavy, but you think they're also going to be helpful in terms of like carrying materials from from the basement to floor number 20 on a construction site in the future as well?
They probably will. Yeah, we've seen so we've had a couple of inquiries actually from industry about that, because we do have one of the bigger drones out there, one of the heavy lift aircraft, and it's a lot cheaper than a crane.
Yeah, cranes are really expensive, and it takes so much, and also it takes a long time for you to pick up something, take it back, and then if there is wind or something, you have to not use the crane, so it's really limited if you think about it.
Yeah, I'm sure there are drone companies that are working on it. It's not where we're focused at as a company, but I can see it adding value to the construction industry. Yeah.
Interesting. Oh, I don't know. For me, it's so impressive doing the mix of software and something that flies. And in particular for Apellix, what's coming on your roadmap in the next, 2 years?
Yeah. So sometime in 2025, we will be launching, for lack of a better word, we're calling it a spot repair, spot touch up, or graffiti remediation drone, where it will not have a tether. It'll have an onboard reservoir and an onboard pump, and it'll be able to fly up to a structure and with distance hold, stay the right distance from it, and apply paint to cover graffiti or to make a spot repair. So that's coming. And then long term, as we complete our project with the U.S. Army, we'll be adding in the production painting capabilities, where it is tethered to the ground for power and tethered to the ground for material transfer. And it'll be able to paint from large industrial structures and large construction walls and different things.
And typically, when you engage with clients, do you always do your work yourself, or you always find a company that manages the drone? Let's say someone in California they buy the drone and they manage it, or sometimes you do it yourself. How does that process work?
Yeah, so we're not a services company. We're a manufacturer. But that said, when we do manufacture a new product, and I'll give the example of the power washing drone, what we did was 2 years of development. Then we did 6 months where we embedded our engineers into a company that was going around cleaning elevated water towers. Then we took our learnings from that, incorporated it into the drone, gave a few of the early models of the drones to some innovative companies that were out there and told them to, hammer on them, stress them, work them really, really hard, receive their feedback, and then put that into the drone and then launch the product. We also do occasional work with companies. We've done some Fortune 50 companies that we've worked with where there's this bespoke product that we will work on, or bespoke project, I should say, where we'll work on a solution that works well for them and fits one of their pain points and does a job for them. One example of that would be right now, it doesn't involve construction or architecture, but the energy grid, the power lines. They have these insulators, and they could be 16 feet tall, and the wires go from the insulator to the insulator as they string along the landscape. And those insulators can get dirty, and they can cause a spark or a loss of power that flows across the wire. So to keep them clean, there's a less risk of a spark and potential fire. There's also less risk of, or there's less loss of energy that's flowing across that wire. So right now, certain locations where there's exposure to salt water, for example, or salt mist or salt air, they clean the insulators quite often. Other places, depending on the environment, they'll clean it more often or less often. But they're doing it with helicopters, and that's expensive. So you got a helicopter, you got a person there blasting water on these insulators to clean them. That's a perfect application for a drone to do. So a couple power companies have been in discussion with us for making the modifications necessary for the power wash drone that we currently have to be able to clean those insulators on the power lines. And there's a lot involved because water is conductive, and these are going to be live. So you have to use special types of water, deionized, demineralized water. You have to know the distance to stay back so that you don't have an arc between the insulator and the stream of water in the drone. And then that arc coming down the drone to the equipment on the ground, So it's a complicated process, but it is, again, showing the versatility of the platform and how it can be extended and fit different use cases for different industries.
Oh, it's really interesting. It's just that every time you need to deal with something as extreme as that example, you need to adjust the code and everything and the complexities, because you will not consider the distance, for example, when you're just washing a facade because there's no electricity there. But if you're doing something like that, you need to consider the arc of the electricity that might hit the drone. So it's just so interesting.
And at our core, Apellix is a safety company. I mean, I founded the company and I wanted to be able to take people from elevation and put them safe on the ground. And when we started out, our main clients were in the oil and gas industry. So to date, we are the only company that I know of that has ever been able to take a drone inside a Class 1 Division 2 hazardous zone inside of an active oil and gas refinery, just because we have that core DNA as our company for safety. And we bring that to everything we do, because these are dangerous tools, right? They're heavy. If they fall on somebody, they could hurt them. The propellers are kind of flying chainsaws, right? So we don't want anybody getting hurt using these. They're built for safety, and we want people to use them safely. So we emphasize that extensively with our products. And even when you buy one of our power wash drones, for example, included in the price is a 4-hour half-day training, where it includes hands-on for an hour and then 3 hours of classroom with safety, best management practices, standard operating procedures. So that is a critical component in the construction industry too. We all have to keep each other safe, and all the tools that we use need to be safe as well.
No, that makes sense. We want less accidents, no more accidents in our industry that is not known for security in general. It's improving, and part of it, I think, it's tools like this that it allows people to, not be as exposed to heights or be hanging from a rope at like really high elevation. So I love when these kind of products help our industry. So thanks for that.
But it's kind of a way of the best and most use of your employees, right? Because you could have an employee doing something manually and that could be dangerous to the employee, or you could have that same employee retrain them and have them operating a machine that's doing that job. And it's doing the job faster, safer, and better. So, the highest and best use for your employees and your labor is not necessarily actually doing the physical task itself. It could be operating something that does the task.
Absolutely. All right, Bob, I don't want to take more of your time. I know you're a busy guy, but before we wrap this up, can I ask you a couple of ping-pong questions?
Oh, absolutely.
All right. Can you tell me the next big trend on the AC?
Yeah. Of course, my answer is going to be software. And of course, it's going to be drones. So, there is some great software out there for AEC for drone video. So right now you have a lot of drones taking photometography or orthomosaics. And now with AI, you can take that to a new level. So that's going to open up a world of additional information. And, what's measured is known. So having additional information, you're going to be able to increase quality and effectiveness and efficacy of the work that you do as the software gets better and better.
That makes sense. If you could collaborate with any person in history, which person would you choose?
Oh, you're going to love this one. Antonio Gaudi. And the reason is La Sagrada Familia. The church in Barcelona. Oh my God, that is such an amazing piece of architecture. And I know without a doubt, if he were alive today, he would want drones cleaning that. Because it's taken so long to construct it. You've got part of it that's dirty, part of it that's clean.
True.
And yeah, you can get up there and clean it with people, but it would be so awesome to have drones going and cleaning that cathedral.
I bet it's going to happen because, the complexities of how you hang people's architecture.
No straight lines. That's the other beautiful thing. Yeah.
So I bet they're going to use drones and
I hope so. Yeah.
Man, that's my favorite building in the world.
Mine too.
The outside is just insane, but the inside, when it's like you're in heaven. You look above and in the colors, and it's just insane that one guy thought of this so many years ago, and it's it's just unbelievable. So hopefully they use drones. And then what's your favorite? And maybe you're gonna say Sagrada Familia, but what's your favorite building in the world?
The Sagrada Familia.
Don't worry, we have that in common. It's just, but it's true. Now that you mention it, is the old facade is really dark, and all the new ones.
It's really white and light. Yeah.
It's really white and dark. So I know they're concentrated on finishing. I think they want to do it next year, right? 2025. I think they want to.
It's coming to conclusion on the 100th anniversary of his death or something like that.
Correct.
Yeah. So it's coming up in the next couple of years. Yeah.
Yeah. The only thing that they don't know if they're going to do is, because actually you're going to access from a second level from the block in the front of Sagrada Familia, and they need to tear down houses. So that's the main problem on where they're gonna finish it, because people are saying we have been here for 100 years. You cannot tear our house down, and they're saying that's the design of Sagrada Familia. The doors are on the second floor, so they need to do it from the block on the front. So. It's going to be fun.
It's a remarkable piece of architecture, remarkable history, just a phenomenal structure.
Yeah. Insane. And before we say goodbye to each other, can you tell everybody where they can know more about yourself or Apellix or drones?
Oh, yeah, absolutely. Thank you very much. So you can go to our website, www.apellix.com. That's Apellix.com. So real quickly, Apellix comes from a portmanteau, a mashup of two words. One is Apis melliflori, which is the hardworking little honeybee, right? And the other is Apelles of Kos. Apelles was a famous painter from antiquity that some say was much more talented than Michelangelo.
That's so profound. I love that the name is such a profound meaning.
Yeah.
Love it. And also, where they can contact you, Bob? Like you're in LinkedIn or Twitter?
Yeah, find me on LinkedIn. Just search for Apellix. I'll be there. My email is bob, B-O-B, @apellix.com, A-P-E-L-L-I-X. Feel free to reach out anytime. I could drone on about stuff all day.
Absolutely. And thanks so much for sharing all this, man. You know so much about drones, and what you guys are doing is amazing. So thanks for sharing all the knowledge and all the amazing things that you're doing.
Thank you. Thank you.
All right. Hope you have a great afternoon.
Thank you. I appreciate it.
All right. Bye-bye.
Thanks to our listeners. If you like this content, you can find past and upcoming episodes in ascworks.everse.com and at all of our Everse social media. We'd love to hear from you and recommendations for new content, so leave us a DM and we'll make sure to catch it.